Hi everyone. In this video we are going to see that why software optimization is very much important. Okay. So once you understand this, then only you will be able to understand that why system design is very much important nowadays in industry. Okay. So let's try to understand this. Okay. In previous video we have learned that what is latency. Okay. Latency is network delay plus computational time. Fine. And we have also seen that network delay is not in our hand, it's client related things. Okay, so as the client has a fast network, once the response object will get ready, it will serve faster. Fine. And this computational time is in our hand. Okay, this is nothing but the time which is taken by a server to prepare the response object is called as a computational time. Okay, so let's suppose we have one program that will give the all the factor of a given number. Okay, factor means if I have a 36, the factors are: 1 is a factor, as 1 can divide 36, 2 is a factor, 3 is a factor, 4 is a factor, then 6 is a factor, then 9 is a factor, then 12 is a factor, then 18 is a factor, and at last 36 is a factor. Okay, so we have to write one program that will give all the factor of 36. Okay, so let's try to write that program. Okay, so we have to execute till n, right? So I is equal to 1, we will be starting from 1, and I is less than n. Let's suppose this is our n. Okay, I plus plus, we are increasing by 1, and we will be checking here that if n modulo I is equal to 0, then that number has divided my n, and we will increase the counter. Let's suppose I have made one counter that will keep the count of how much factor this particular number have. Okay, so this is a very simple program that will give the factor of all the factor of given number. Okay, so how many instructions are there in one iteration? Let's check that. This is initialization part, so it will execute only once. What about this? This will execute n numbers of time. We will be checking every time this condition, right? And once the condition is checked, based on that we will increase. So this is also going to execute n numbers of time. What about this modulo? This also going to be done every time, right? I mean n numbers of time. What about this equal operator? Okay, this is also going to be execute n numbers of time. Okay, what about this? I can say that this can happen or this may not happen. Okay, let's suppose number is very large, that means it will happen only once, right? Because we are executing till n. So if number is very large, it will happen only once. So for the benefit of the doubt, we will not include this. Okay, so we have total 4 instruction in one iteration. Okay, so we have 4 instruction in one iteration. Fine. Okay, have you heard about this? I have a that processor can be 1 gigahertz, 2 gigahertz, 4 gigahertz, 8 gigahertz. Okay, so what this means? This means that my processor is capable to execute 1 into 10 to the power 9 instruction per second. Okay, what about this? This means it can execute 2 into 10 to the power 9 instruction per second. Okay, what about this? It can execute 4 into 10 to the power 9 instruction per second. Same for this, 8 into 10 to the power 9 instruction per second. Okay, so let's try to calculate the factor for the number 10 to the power 9. Okay, we have to calculate all the factor for this number. Okay, So what will happen is, how much time it will take. Okay, let's see how much time it will take this program to calculate factor for this number. Okay, so it will take, it is going to iterate till n. Okay, so 10 to the power 9 iteration it will take. In one iteration we are executing 4 instruction. Fine, so 4. So this is what, this number of instruction will get executed in all. Okay, to calculate 10 to the power 9 factor, I need to execute these many instructions. Fine, now let's try to calculate that how much time my 1 gigahertz processor will take to execute these many instructions. Okay, so we have one simple formula, that is number of instruction, number of instruction divided by processor, power of processor, power of processor. Okay, so let's try to put this in our formula. How many instruction we have? 10 to the power 9 into 4. Okay, these are instructions. Fine, and we are calculating for 1 gigahertz, how much time my 1 gigahertz processor will take to execute this many instruction. Okay, so power of processor is 10 to the power 9 instruction per second. Fine, I can write like this: 4 into 10 to the power 9 instructions. Fine, 10 to the power 9 instruction per second. Okay, so 10 to the power 9 will get cancelled and we are left with 4 seconds. Okay, so my 1 gigahertz will take around 4 seconds to execute 4 into 10 to the power 9 instruction. Okay, so let's double this number. Okay, now we have to calculate for n equal to 10 to the power 18. Okay, so what will happen now? Let's try to fill this in our formula. Okay, before that we will check that how many instruction this n will contain. We have, in one iteration we have 4 instruction, so how many iteration we have? 10 to the power 18. Okay, so we will write here in our formula, number of instruction we have 4 into 10 to the power 18. Okay, we are calculating for 1 gigahertz, that is, these are instructions. Okay, and 10 to the power 9, power of my processor is 10 to the power 9 instruction per second. Fine, so I can write like this also, right? 4 into 10 to the power 9 into 10 to the power 9 instruction. Fine, and here it will be like 10 into 10 to the power 9 instruction per second. 10 to the power 9, 10 to the power 9 will get cut and we are left with 4 into 10 to the power 9 second. Good. Okay, so can you imagine how much time it will be? Okay, this is in second. Let's try to convert this in a year. Okay, so 4 will be like this: 10 to the power 9 second. If I want to convert second into minute, how can I do? I will divide by 60. Okay, if I want to convert into hour, I will divide by 60. If I want to convert into day, I will divide by 24. If I want to convert into year, I will divide by 365. Fine, so if you do the calculation, I have done already. So if you do this calculation now, you will get 4 into approx 31 year. Okay, so these, and let's simplify this, you will get around 126 year as an answer. Okay, so can you imagine this program to find a factor for 10 to the power 18 will take around 126 year. Okay, so this is not a efficient. Okay, this is not a efficient way. Why software optimization is very much important. Our this is very this was very small program and it is taking around 126 year. Okay, so this can impact your business a lot. Okay, so let's try to visualize the optimal code for this. Okay, so 36 we have, and the factor are 1, 2, 3, 4, 6, 9, 12, 18, and 36. Okay, so these are the factor of 36. 1 is the factor of 36. If I divide 36 by 1, I will get 36. Can I say 36 is also a factor of 36? Yes. 1 is also a factor of 36 and 36 is also a factor of 36. Fine. 2 is a factor of 36. If I divide 36 by 2, I will get 18. Can I say 18 is also a factor of 36? Fine. 3, 36. 3 is a factor of 36. If I divide 36 by 3, I will get 12. Can I say 12 is also a factor of 36? Yes. 4 is a factor of 36. If I divide 36 by 4, I will left with 9. Can I say 9 is also a factor of 36? Yes. 9 is also a factor of 36. Okay. 6 is a factor of 36. If I divide 36 by 6, I will left with 6. So 6 is also a factor of 36. Okay. So from here you can see that we don't have to go till n. If I go till 36, square root of 36, that is 6. If I go till 6 now, I will get my all the factor. Correct. Let's try to analyze for 25. Okay. So factor of 25 is 1, 5 and 25 itself. Okay. 1 is a factor of 25. Yes, if I divide 25 by 1, I will be left with 25. So 25 is a factor of 5. Okay. 5 is a factor of 25. If I divide 25 by 5, I will left with 5. So 5 is also one of the factor of 25. Now I don't need to go forward because we got all the factor. Okay. So we just need to execute till square root of given number, that is 5. Okay. So we had a problem of for n equal to 10 to the power 18. Okay, so from here what I can say is I don't need to go till 10 to the power 18. I can write 10 to the power 9, 10 to the power 9. Correct. I can write 18 like this and I will take square root of this. I will left with 10 to the power 9. Correct. So let's try to analyze this, that how much time my 1 gigahertz processor will take to execute these many instructions. How much total number of instruction I have is 4. One iteration will take one iteration contains 4 into 4 instruction. So how much instruction my 10 to the power 9 will contain? So 4 into 10 to the power 9 instruction. Correct. And the power of processor is 1 gigahertz, that is 10 to the power 9 instruction per second. Okay, so 10 to the power 9, 10 to the power 9 will get cut and we are left with 4 seconds. Can you imagine, we have bring around 126 year 126 year to 4 seconds. Okay, by doing optimization in our code, we have bring the 36 year to 4 seconds. Okay, so this is why software optimization is very much important. Your hardware optimization may not be efficient, but every time doing a hardware adding a hardware to your system may not be efficient for your organization or for your business. Okay, so we need to go for the software optimization. So this is the reason nowadays in industry system design is very much important. Okay, so that's it for today. So we will meet in next video. Till then, take care. Bye bye.